Hi, welcome back to Maths Learning Groups. Now today we are going to continue with our exam papers. All right, question 16 and usually the question 16 and 17 they are the hardest. Okay, the one of the hardest questions. But sometimes it may not be necessarily so. Sometimes the 16 or 17 can be actually quite easy, especially when it comes to finding a pattern. Right, it can be quite easy. But otherwise, you will usually find the questions are quite hard in the last two questions of the exam papers. All right, so let's look at this question. And let's see what kind of question is this. Now, like what I told all my students, when you tackle any exam question, there are some general questions that you need to ask. The first general question you need to ask is the question a story sum or is it not a story sum? If it's a story sum, then what do? Then you ask the next question. Is it a before and after or is it not a before and after? And if it's a before and after, then what do? Then you need to ask what is unchanged. And what methods do you use when you have before and after problems? You have the table method. You also have the drawing, right? The model drawing. So there are a few methods you can use to solve before and after problems. But if it's not a before and after problem, then what other methods you can think of? Assumption method. You can think of grouping method, systematic listing. So these are methods that you can use for story sums that are not before and after. But otherwise, if it's a before and after problem, then what is the method, the most suitable method that we can use? Model drawing or table method. So in this question, it's a before and after. So we have to think about what is unchanged. So June and her Kevin have a collection of game cards. If June gives Kevin half of her game cards, Kevin will have 72 more than June. If June gives Kevin 1/6 of her game cards, she will have 16 fewer than Kevin. How many game cards do they have altogether? Now, this question belongs to those questions that like some tutors or some teachers, they call it the double if. Okay, the double if question. Okay, there's one if here, there's a second if. They call it the double if or the two if. Okay, now what kind of method do we use to solve this? It is a before and after. So we have a what? We have a table method. Right? Can we draw model? Yes, we can draw model, but it is going to be hard for most students unless you can draw. Otherwise, you will need to have an alternative method, which is your table method. Alright, so because it's a double if, so there are two tables. And what is unchanged? The total is unchanged. And that's important because if you know that the total is unchanged, it will help you to solve the problem easier. Okay, so total is unchanged because there is a transfer. Okay, so you have the BCA for the first table and the second table, BCA. And then you have June, you have Kevin, you have total, you have June, Kevin, and you have total. Okay, alright, so put the numbers inside. If June gives Kevin half of her game cards, now when you put in the boxes, the first box that you put, alright, the first box you put in cannot be a fraction, right? It can't be a fraction. It has to be a number, actual value, or it has to be units. Okay, it has to be units or parts. So you can't put a fraction into the first few boxes. Alright, so that is one of the lessons on table method. Right, because if you were to put, like for example, June give Kevin half. If you were to put something like this, then if you find it's going to be a bit hard because your 2/2 is equal to what? Right, there's nothing to equal to. So I don't put fractions in at the beginning when I fill in the boxes. So what do? I actually break up the fraction, and instead of putting the fraction into the boxes, June give Kevin half, which means that 1 unit, and she must have 2 units at first. She give Kevin 1 unit, and now she has 1 unit left. Okay, so that is what I will put in the first few boxes. Then you have something in the boxes already. And then later on, you can put your fraction inside, and then your fraction will be equal to whatever that's inside the box. Okay, and then this 1 unit will go to Kevin. Okay, and then Kevin will have 72 more than June. Okay, Kevin will have 72 more than June. That will be 1 unit and 72, and the total is 2 unit and 72, right? And of course, how about Kevin? Do we know Kevin has how many at first? We are not sure. Okay, we are not sure. So what do? We are not sure, right? So we don't put anything inside. Okay, we don't put anything in the box. Got it? right? See, anything you're not sure, you don't put in the box. And then go to the next one. If June gives Kevin 1/6 of her game cards, so June, instead of putting the fraction again in the box, June has 6 parts, and you can't use 6 units because you already have units already. And she gave 1/6 or 1 part, and now she has 5 parts left. And the 1 part goes to Kevin, right? Kevin. And now she will have 16 fewer than Kevin, or Kevin has 16 more than 16 has fewer, or Kevin has 16 more than June. So there'll be 5 part and 16, right? Got it? So that's how you fill in the boxes. So after June give Kevin 1/6 or 1 part, and then now you can see that June has 5 parts, Kevin has 16 more than Kevin. I mean, Kevin has 16 more than June. Okay, so what's the total? 10 parts and 16. Okay, 10 parts and 16. Okay, if you were to work backwards, okay, you work backwards, and then what do you see? Now, can we find Kevin has how many at first in the first table? That will be 72, right? Okay, and then of course the total at first is 2 unit plus 72. How about the second table? The second table, you work backwards. Kevin has how many at first? That will be 4 parts plus 16. So the table is very special. It can go this way. Alright, that's the normal way of doing. Or it can flow backwards. Right, it can go this way, it can go back. So 5 part minus 1 part, your plus 1 part become minus 1 part, and that's how you get 4 part and 16. So Kevin has 4 part and 16. If you add them together, the total is unchanged, right? Okay, so we are done. And then what do you do? And the rest are simple already. So how many cards do they have all together? So your question mark all together. So here, total is unchanged. So there are actually 4 question marks that you can choose, and you will still get the same answer. Okay, so total is unchanged, and our table is done. So what is the next step? Now, the next step is simple. Now, the 2 table has 2 same person, right? So the first table has somebody called June, and the other table has the same person called June. And what do you see? They must have the same number. June must have the same number at first. So which means that your 2 unit is equal to 6 part, 1 unit is 3 parts. So if 1 unit is 3 parts, let's change everything into parts. So if there are 2 units, that will be 6 parts, and 1 unit will be minus 3 parts, and June will have 3 parts left, and this plus 1 unit become plus 3 parts, and then this 1 unit will become 3 parts. So everything become what? Become parts, right? Parts. And the total will be 3 part plus 3 part will be 6 parts and 72. Okay, 6 parts and 72. Okay, and of course this one will be 6 parts plus 72. So everything all become the same. Total unchanged, right? Total unchanged. Okay, what else do we do next? Okay, now you can see that if you look at the total in the 2 tables, right? This total, for example, and you look at the total in the other table, the total is unchanged. So which means that your 6 parts plus 72 is equal to 10 parts plus 16. And the rest you can do already, right? I'm sure most of you can continue with this. So you minus 6 parts, you get 4 parts, minus 16, here minus 16, you get 56. So your 4 part is equal 56, 1 part 14. Okay? And if your 1 part is 14, then you can find the total, right? Total, which is 10 part plus 16 or 6 part plus 72. Either one will give you the same answer. So let's choose 10 parts. 10 part, which is 14 times 10, 140, and 140 plus 16, that will be total 156. So which means that they have all together 156, right? 56 watts, 156 game cards all together, right? And if you look at the other table, do you think you will get the same total? 6 part plus 72. So what is that? So you take 6 times 14, right? 6 times 14, you get 84. 84 plus 72, and you also get the total unchanged. right? So that is the table method, right? The table method, and okay, do pardon my steps because my steps are all over the place. Okay, they're all over the place, but otherwise, this is how you do how you solve the problem using the table method. How about the model drawing? Well, model drawing is going to be hard for many students because first of all, number one, you don't practice your drawing usually, right? Most students don't practice their drawing, so for them to draw this problem is hard. Okay, it's hard for them to draw this problem. So model drawing is going to be quite hard for many students. So what do? Then you will have to change your method and do a table method. Okay, now what happens if table method you also not aware or you also do not know how to use? Then it's going to be super double hard for you already. You have to think using your brain power. So like what I said, methods are there to help you, right? Methods are there to help you to do easier, solve faster, and with less thinking. So if you don't have the methods or you continue to not use the methods, like some students, they don't want to use the method, they just want to do their own style, right? They want to do their own way, and then what happened? You find that they struggle, right? Because unless you're very good in math, otherwise you really struggle to think on how to write out the steps. But with the methods, you don't have to think because the table method guides you to do what's the next step. So this is how you should be doing. If you want to think lesser, do your methods, use your methods, go and learn the methods, and that's how you do better. All right, you don't have methods, then you work very hard already. You have to work very hard but not very smart. Okay, so we come to the end of this lesson, and stay tuned to the next lesson. So we will continue to look at other exam questions, and we will use different methods to break it down, and that's how you do well for your paper 2, right? Not very hard, it's actually quite fun, right? Using your methods to choose the right weapon to attack the right problem, right? Okay, so see you in the next lesson.